Hello, this is Dr. Muralidhar from Department of Textile Technology, AC College of Technology, Anna University, Chennai, deliberating on basic weaves. A brief introduction on basic weaves. Woven fabric design or weave are composed of warp and weft threads according to the form of design that are desired to desired. The repeat or a pattern is a small unit of weave repeating on a specified number of ends and picks, which when repeated produce the required design. The weave influences the aesthetic as well as the properties of the woven fabric. The interlacement pattern of the woven fabrics are manipulated using the drafting order and the lifting plan. The weaves are constructed on a point paper using cross marks and blanks. A cross mark in a point paper means warp up, whereas a blank means the weft up. Woven fabric structures may be broadly divided into two principal categories: simple structures and compound structures. Simple structures is one series of warps and one series of weft, whereas in compound structure there is more than one series of warp and one series of weft, whereas some are used for the design purpose, ornamentation, and others are used for the ground structure. The learning objectives of this module is to understand the construction of basic weaves and to learn about drafting and lifting plan and to learn about a few fancy weaves. Weaves are the pattern of interlacement of the corresponding warp and weft threads. A weave repeats on a definite number of ends and picks, and the number of ends and picks in a repeat may be equal or unequal. The lifting plan is a selection of heels to be raised or lowered on each successive insertion of the weft. Lifting plan indicates the order in which the heel shaft should be lifted for successive weft insertion to produce a particular weave or design. This depends on the weave and its drafting plan. The draft indicates the number of heels required to produce a design, and depending upon the number of ends working differently, the number of heel shafts varies. Drafting order determines as to how the warp ends are drawn through the heels, that is, which end passes through which heel. Number of heels depend on number of ends working differently. This implies that if the interlacement pattern of a thread is same, then they should be drawn through the same heel shaft. In a straight draft, a slanting line is formed by crosses across the point paper as shown in figure. This means that each end of the design works differently. As such, the end needs to be drawn through a different heel shaft. Coming to the pointed draft, as the name indicates, it's a pointed draft. The weave repeat contains ends working with similar interlacements. As such, for a weave repeating on 7 ends, only 4 heel shafts are required, as shown below. And the skip draft. Skip draft is useful in weaving very dense and close-set fabrics, where normally a small number of heels are required. This system reduces the friction and rubbing between the ends by using more heels than the minimum necessary. In a skip draft, more than one heel shaft are controlled by the shedding mechanism. For example, plain weave textiles can be woven with 2 heels, but when producing textiles with high number of ends and picks per unit area, it is often suitable to use 4 heel shafts to reduce the jamming of threads in the heels. The skip draft for plain weave is shown in figure. The denting. During weaving, warp ends are spaced out across the width of the warp sheet according to the desired density by wire rates. The denting order frequently used being 2, 3, or 4 ends per dent. Plain weave. Plain weave is used to a greater extent than any other weave. It is the simplest weave, repeating on 2 ends and 2 picks. Each warp yarn passes alternatively above and below each weft yarn similarly. This weave has the maximum number of interlacements compared to other weaves, hence the fabric is stronger and compared to all other materials. Further, the crimp of the yarn in this weave is also higher than other weaves. Plain weave interlacements are shown on point paper in figure 4. Plain weave can be produced on a loom with 2 heel shafts. Plain weave derivatives. In the plain weave derivative, the plain notations are extended in warp or weft direction, or both in warp or weft direction, namely warp rib, weft rib, or mat or basket weave. All plain derivatives can be produced using 2 heel shafts. Warp rib. In a warp rib weave, the plain notation is extended for one additional pick in a group, that is, 2 or more picks are inserted in the same shed. With the warp ends floating over 2 picks, the warp rib becomes distinct in the warp direction of the fabric. As the weft yarn undergoes more number of interlacements compared to the warp ends, the weft crimp is higher than the warp crimp. Further, due to the nature of interlacement, the warp direction has higher tear strength compared to any equivalent plain cloth having a similar aerial density. Figure 5 shows the drafting design and lifting plan of a warp RIB. As shown in the figure, you can see there are two ends, warp end 1 and warp end 2, and the plane mark in the warp end is extended for two picks, and similarly for the warp end 2, the interlacement is extended on 2 picks. And for this weave, we require 2 heel shafts. The threads of the warp end 1 is drawn in heel shaft number 1, and the ends of the warp end 2 are drawn through heel shaft number 2, and the lifting plan is very similar to the design, basic design. Weft RIB. In a Weft RIB weave, the plane notation is extended for one or more additional warp end, that is 2 or more warp ends weaved together as one. With the weft pick floating over 2 ends, the weft ribs become distinct in the weft direction of the fabric. As the warp yarn undergoes more number of interlacements compared to the weft tip, the warp crimp is higher than the weft grip. Further, due to the nature of interlacement, the weft direction has higher tear strength compared to any equivalent plain fabric having similar aerial density. Figure 6 shows the lifting design, draft and peg plan of the weft rib structure. In this figure, you can see that the weft mark is extended to the 2 additional warp ends, and again you require 2 heel shafts to operate this thing, and the design is very similar to the basic plane weave. The lifting order is similar to the plane weave. Mat or basket weave. In a mat weave, the plane weave marks are extended both in the warp as well as in the weft direction, that is 2 or more warp ends and 2 or more weft picks in 1 or more directions. With the warp end floating over 2 picks and weft end floating over 2 ends, the minimum number of ends and picks required for the formation of a mat weave is 2 by 2. Further, due to the nature of interlacement, the tear strength is higher in both the directions compared to any equivalent plain woven fabric having similar aerial density. We are coming to the second basic weave, which is a twill weave. Twill weaves are characterized by the diagonal line formed across from left to right or from right to left. The angle of twill varies between 15 to 75 degrees. The simplest twill weave repeats on 3 ends and 3 picks. Compared to plain weave, the twill weaves have lesser number of interlacements and the crimp is lower. Twill weaves are further classified into warp weft or balanced twill based on the prominence of either warp or weft. Twill interlacements are denoted by using numbers above and below a line, such as 1 by 2 interpreted as 1 up 2 down. There are several types of basic weaves such as 2 up 1 down, 2 up 2 down, 3 up 1 down, 1 up 3 down, etc. In a warp faced twill weave, the warp ends float more predominantly over the weft ends, whereas in a weft faced twill weave, the weft ends or the picks float more predominantly over the warp ends. If the face side of the cloth contains warp faced twill, the back side of the same cloth will have weft faced twill weaves. However, in balanced twill weave, the floats of the warp and the weft yarns would be equal. Figure of a warp face, you can see the figure. There is a 2 up 1 down twill where there are 2 warp ends lifted to one this thing. Whereas you have the next figure, which is 2 up 2 down, which is an equal phase twill, 2 up 2 down twill, which is repeating on 4 ends and 4 picks. Twill angle. Twill angle. Figure 9 illustrates the twill angle made by the twill line with weft or horizontal direction. It depends on the move number and the design of the ends and picks spacing. So you can see the different angles which the twill line can form. It can vary from 15 to 75 degrees. Pointed twill. In a pointed twill, the characteristic diagonal line formed with the direction at specified intervals, thus creating the pointed effect on the textile. The pointed twill based design is woven using a pointed draft, and the lifting order resembles the left hand side of the design. Here you can see the pointed design, which is working on a 4 end this thing. They have 2 up 2 down twill is basic twill is used, and the number of ends which is repeating on is 7. So the design is turned or pointed from the 4th end onwards, You can see that end number 1 is drawn in heel shaft number 1, end number 2 in heel shaft number 2, end number 3 in heel shaft number 3, and end number 4 in heel shaft number 4. Whereas end number 5, which the interlacement is similar to end number 3, is drawn in the heel shaft number 3. And similarly, end number 6 is similar to end number 2, which is drawn in the same heel shaft, and similarly the end number 7 is similar to end number 1. So the ends working similarly are drawn through the heel shaft, though the number of the design repeats on 8 ends and 4 picks. The number of heel shafts required are 4, and the lifting order is also on 4 ends and 4 picks. Yeah. So the third of the basic weaves is a satin or a satin weave, which is characterized by smooth appearance without the continuous twill line, with only one binding point in each end and pick in the design repeat. Satin fabric is characterized by high luster on one side of the fabric. Satin weave is warp faced, whereas satin weave is weft faced. For the construction of satin weave, a feasible move number is chosen, and using this move number, only those points are marked on the point paper where the end is floating on the pick. Figure 11, example of a 7-end satin with all possible moves, is move number is shown. As you can see in the figure here, for a 7-end repeat, 1 by 7, the move number is 1. The first end there is 1 interlacement. The second end is 1 move right and 1 move up. The third interlacement is 1 move right and 1 move up. And in this way, you can see move number 1 produces a diagonal twill. Whereas in the second you can see the move is 2 move to the first interlacement. So the first interlacement 2 move right and 2 move 1 up, 2 move right, 1 up, 2 move right and 1 up. So in this way you can see that there are only 1 interlacement in each thread, each warp and weft thread, and there are no prominent diagonal lines. Similarly, in figure number 3, in the third you can see the move number 3. From the first interlacement, the move is 3 to the right and 1 up, 3 to the right and 1 up, 3 to the right and 1 up, 3 to the right and 1 up. In this way you can see that the diagonal line is also lost, whereas you can see there is only 1 interlacement in each warp end. With move number 4, you can see again from the point of interlacement, first interlacement, 4 move to the right and 1 up, 4 move to the right and 1 up, again you get a satin weave. Similarly, with move number 5, you get a satin weave, as there is only 1 interlacement each warp end and weft introduced, whereas move number 6 produces a right hand twill, which is the diagonal line is from right to left. So you can see that all the moves are not possible. Move 1 and move 6 cannot be used for construction of satin weaves. Rules for making satin weave: it is observed that move number 1 and n-1 produce twill weave, hence cannot be used. Here n is the repeat size of the design. The move number and repeat size of the design should not have any common factor. However, move number 2, 3, 4 and 5 produce valid satin weaves. On a point paper, the satin weave can be converted to satin weave by interchanging the cross marks with the blank spaces and vice versa. And going to the fancy weave. Honeycomb. Honeycomb weave produces ridges and hollow which give a cell-like appearance to the cloth textiles. Both the warp and the weft thread float freely, show prominent diamond shapes on the fabric created by a long floats on both sides, coupled with a rough structure which absorbs moisture readily. Honeycomb designs can be produced with pointed draft, and thus the lifting plan resembles the left hand side of the design. The weaves are of 2 types: ordinary honeycomb, which produces similar effect on both sides of the cloth. Here you can see an ordinary honeycomb produced on 11 ends and 8 picks. So you can see the diagonal line from left to right being produced, and then on from right to right, and you can see the number of the warp and the weft floats being this thing. Whereas you can see the number of heel shafts required is only 5 heel shafts, and the pointed draft being used to convert this ordinary honeycomb. And the lifting order is very similar to the left half of the design, so which is you just transfer the interlacement from the left half as it is. When we go to the Brighton honeycomb, which produces cellular formation on one side of the cloth only. Construction of Brighton honeycomb is quite different from ordinary honeycomb and requires to be woven in straight draft. Further, the number of thread in the repeat must be in multiples of 4. The diamond base is first made by inserting a single row of mark in one direction and a double row of mark in the other direction. Marks are then added to the double row so as to form a small warp diamond in the right and left corner of each diamond space as shown in figure 13. So as you can see in the figure 13, is a 16 thread Brighton honeycomb. In this you can see the prominent diagonal mark created by introducing cross marks from left to right. Then you can see the double the cross lines which is introduced from right to left, and to this additional marks are added to produce the diamond shapes. You can see there are 2, 3, 4 diamond shapes in all, and this is a single sided this thing is produced. This is the Brighton honeycomb Mocklino. In a Mocklino weave, some of the ends have interlacements, whereas the other ends have long floats. The fabric shows small holes created by the grouping of threads. The weave produces effects similar to gauze or lino. A Mocklino weave having a repeat size of 10 by 10 is shown in figure 14 along with the drafting and the lifting plan. Only 4 heel shafts are needed as the interlacement pattern of ends 1, 3, 5 are same, and they are drawn through heel shaft number 1. Similarly, the interlacement pattern of ends 2 and 4 are same, and they are allocated heel shaft number 2 and so on. So here you can see a Brighton honeycomb 10 by produced on 10 by 10, and you can see the number of heel shafts required are only 4 heel shafts, and the design and the lifting order is constitutes of 4 heels. Huckaback. Huckaback weaves are largely used for cotton towels. The structure is so arranged that the plain weave gives very hard wear and firmness, whereas the loose floats pick up good moisture. Huckaback weaves have some similarity with the Mocklino. A 10 by 10 huckaback weave is shown in figure. If the design is divided into 4 quadrants, then the top right and the bottom left corner are having similar interlacements. However, the remaining 2 quadrants have plain weave like interlacement patterns. Therefore, some of the ends, end 2, 4, 7 and 9, are having long floats followed by regular interlacements. And the design shown below requires 4 heel shaft. So you can see a 10 by 10 Mocklino with interlacements of plain on the 2 opposite quadrants and floats on 2 opposite quadrants, and there you can see the design is produced on 4 heel shafts. This is about the huckaback view. To sum up this module, I would like to revamp the different points we have discussed today. As to first thing about the different basic views which we have studied, the plain weave, the twill weave and the satin weave, and further the fancy views which we have studied, and then the importance of the drafting order, which determines the order in which the weave is being constructed, and the lifting plan, which is generally depending upon the design, it is design or part of the design. So you know the design, the basic views, there are 3 basic views and its derivatives, the plain views, how it is derived, how the plain marks have been extended, and how the Weft RIB and the basket views have been constructed, and the number of heel shaft, though the design repeats on a larger number of ends and picks, the number of heel shafts required to produce a basic plain weave remains 2 heel shafts. Whereas in twill weave, we have seen that the basic plain twill weave repeats on 3 ends and 3 picks, and the minimum number of heel shafts required is 3 heel shafts, and thereby we have seen how the draft can be converted from a straight draft to a pointed draft, and increasing the base of the design. And in fancy weaves, in the satin weaves, we have seen both the warp and the weft satin weaves, in which the satin, how the different moves are selected to break the twill monotony and to give a lustrous effect to the fabric. So the face side of the fabric is a satin, a weft face, and the reverse of the fabric is a satin weave. Continuing on this thing, we have seen about the fancy weaves. We have seen about the Mocklino weave, the honeycomb weave, and the Brighton honeycomb weave, and this thing which are used for towel materials generally, which have long floats and have good absorbency.